My name is Shara Alia binti Muhammad Zamri. My metric number is 2319102, and I'll be presenting the introduction for our machine learning project. In this study, we focused on customer churn prediction, which means identifying customers who are likely to stop using a company's service. This problem is especially important in the telecommunications industry, where losing customers can lead to major revenue loss. To address this, we used a high-dimensional dataset from the telecom sector that includes customer demographics, service usage, and payment information. Our main goal was to build a predictive model using a backpropagation neural network, or BPNN, since it can learn complex patterns and relationships in the data. We also applied feature selection and feature extraction techniques, specifically the chi-square method and principal component analysis (PCA), to see how they affect the model's accuracy and performance. Overall, this project shows how data preprocessing and feature engineering can make machine learning models more efficient and reliable. For the dataset, we used telcocustomer.cvs that we got from Kaggle. It includes data from more than 7,000 telecom customers with details about their demographics, service usage, and payment information. The target variable is churn, which indicates whether a customer has left a company or not. Overall, this dataset is high-dimensional and well-suited for exploring feature selection and feature extraction techniques in our study. Now, let's look at the feature selection. We performed it to keep only the most relevant features for predicting customer churn. First, we removed irrelevant columns like customer ID and gender, since they don't provide useful information for prediction. Then, we used a filter-based method called SelectKbase with a chi-square test, which scores each feature based on its relationship with the churn variable. From there, we selected the top most important features. This process helped simplify the dataset, reduce noise, and improve the neural network's focus on meaningful inputs. Next, we applied feature extraction using PCA. PCA helps reduce the number of features while keeping most of the important information from the dataset. It does this by transforming the original, often correlated features into a smaller set of new features called principal components. In our case, we kept enough components to preserve 95% of the data's variance, which means we still retained almost all the useful information. This made our BPNN train faster and reduced overfitting, while maintaining strong predictive performance. Lastly, we are going to look at the performance analysis. The results showed that the baseline model achieved an accuracy of 80.13%. The chi-square feature selection model slightly decreased to 79.42%, and the PCA model performed the best at 80.34%. Overall, PCA gave the best balance between accuracy and generalization, while all models predicted non-churned customers more accurately.
Hello and Assalamualaikum. My name is Nur Balkis binti Nurul Salihin. Metric number 2314032. I'll be presenting our code on customer churn prediction using a neural network model. The goal of this project is to predict whether a telecom customer will leave the company based on their account information and service usage. First, we import all the necessary Python libraries. We use Pandas and NumPy for data manipulation, scikit-learn for preprocessing, feature selection and modeling, and matplotlib for visualization. And we also use Google Colab import files to upload the dataset directly into the Colab environment. So next, after loaded the dataset, we drop columns that weren't useful for prediction, like customer IDs and gender, since it doesn't strongly affect the churn in this dataset. We also handle total charges column, which contains some missing non-numeric values. We convert it into numeric, then replace missing value with the column median. And then we encode categorical data, which we have several of it, such as internet services, contract, and payment method. We convert all this into numeric form so that they can be used by machine learning algorithm. Next, we split the features and target into X and Y, and then we standardize the data using standard scaler. We also use min-max scaler when applying the chi-square features, since chi-square require non-negative data. And then we split and test the data sets into 80% training and 20% testing. And then we have model 1 NLP classifier on original data. We use one hidden layer with 10 neurons and train it up into 1000 iterations. After training, we evaluate the model on the test set, and then if the accuracy we will be shown later. And then model 2, feature selection using chi-square. We select top 10 features that have the strongest relationship with churn, and then we retrain another MLP classifier using only those features.
Assalamualaikum warahmatullahi wabarakatuh. My name is Farah Amira and my metric number is 2317648. So I will continue to present the Python code starting from the PCA feature extraction. So in this line, it means that we kept only enough principal component to retain 95% of the total variance in the data. So after that, we transform the scale dataset into XPCA, which now contains fewer but more meaningful features. Finally, we split this transformed data into training and testing sets, ready for model training. Okay, next, we train a backpropagation neural network using the PCA transform data. The model uses one hidden layer with 10 neurons and runs for up to 1000 iterations. After training, we tested the model to predict churn on the test data and calculated for its accuracy. This model is labeled as BP with PCA in the results. This one. Okay, next for the evaluation results. The result shows that the original model without any feature selection or extraction achieved 80.13% of accuracy. Meanwhile, the model with feature selection had 79.42%, slightly lower due to fewer features. And the model with PCA achieved 80.34%, which is the highest among all three. This shows that PCA helped improve the performance slightly by reducing noise and focusing on the most informative components. Okay, now for the confusion matrix. The first confusion matrix, which is for the original data, shows that the model performed using all features. It has balanced prediction between churn and non-churn customers, but still with some misclassification. The second confusion matrix for feature selection looks slightly less accurate. The model might have lost some information when we reduce the number of features using the select k-bets. And the third confusion matrix shows improved performance again, with clearer separation and more correct predictions, indicating PCA preserved most of the essential variance from the data. Okay, lastly for PCA variance plot. This graph shows how much variance each principal component explains. The x-axis represents the number of components, and the y-axis shows the cumulative explained variance. As we can see, the curve rises quickly and crosses 95% after a few components. That's why we set n components equal to 0.95 earlier. It means PCA was able to reduce dimensionality significantly while keeping all the important information from the original datasets. That's all from us. Thank you.